Hi, I'm Thomas from Thomas Teaches. And today we'll be learning about Newton's method! Come hither, my sweet children, and follow me into my classroom. Come on. Come on, guys, are you coming? Come right in, kids. Come on. And remember, kids, this election cycle, vote Ted Cruz for president, the Christian conservative that this country needs. Choose Cruz. Now, the point of Newton's method is to use derivative calculus to solve for the zeros in a function such as f of x, as pictured here. Now, the point of Newton's method is to find in a function f of x a point x of 2 where the roots of x of 2 is. Now, we can use x of 1, a point close to x of 2, and find the derivative of f of x at x of 1. So, let me write this down for you kids out there. F prime of x of 1. Now we can use f prime of x of 1, which we found, of course, with derivative calculus, to create a tangential line, which is seen over here. Now, this tangential line to f of x at x of 1 is going to, we're going to use that and find the root of that function. So where crosses the x-axis? Now, we can do this process as many times as possible and keep on finding points closer and closer until we get a good approximation of where exactly x of 2 is.
Good job, Professor.
Hey, gee whiz, thanks kids. Warning, math is about to happen. Now we're going to derive the function. Now we already know that y prime equals y2 minus y1 over x2 minus x1. Simple math, I would say. Now, we're trying to find x2 because that's the entire point of Newton's method. So doing some simple algebraic work, we're going to get y prime times x2 minus x1 plus y1 is equal to y2. Now, of course, we already know that y2 is a root, so it's going to be equal to 0. After doing some more algebraic work, some simple distributive property, and getting some variables on both sides, the desirable side of the function, we're going to end up with x2 equals x1 minus y1 over y prime. Simplified, in easier terms to understand in terms of f of x, we're going to get x2 equals x1 minus f of x of 1 divided by f prime of x of 1. This is the basis function of Newton's method. Let's do an example now, kids. Now we see here f of x is equal to x squared minus 2. Now if we want to find the value of x of 2, we can use Newton's method, which the equation, come on kids, we already learned the equation. X of 2 is equal to x of 1, a value close to x of 2, minus f of x of 1 over f prime of x of 1. Now, of course, we know that x of 1 is equal to 1, just given with the problem. Now, if you want to find f of x of 1, you can just plug that into the function f of x. So f of 1 is equal to 1 minus 2, which is equal to negative 1. Now, of course, a little bit more tricky, I'd say, under my own approximations, is finding f prime of x of 1. Now, f prime, using derivative of f of x, would be equal to 2x. Now, if you want to plug in 1, which is x of 1, into that function, you get 2 times 1, which is equal to 2. Now, this will all add up to x2 equals 1 minus negative 1 over 2, which is equal to 3 halves. Now, to shorten the simplification process down, we all know that we're going to keep on doing this until we can get the exact correct value, which, computed, is radical 2, or, as we all know it, 1.41.
Professor, what if the function has no zeros?
Sean, that's a stupid question.
Mr. Thomas, can I use the restroom?
What?
Are you okay, Mr. Thomas? Don't.
Ground control to Major Tom. Ground control to Major Tom.